This question is particularly apt for people who have done a little bit of work in Python 2, but it's also pretty important for Python 3. And that's, what's the difference between the str and bytes types? So let's talk about this a bit. Let's say I have some text, s equals a, b, c, d, e. In memory, how is this represented? Well, back in the olden days of Python 2, this was represented as a series of bytes. And each byte is an 8-bit number, right? So from 0 to, I guess, 256? Yeah, it must be 256. There we go. Showing off my math skills right here. And you had 256 different characters that you could display in a single byte. Now, the first 128 of these were known as ASCII. And so basically we had room for Latin letters, right? The English alphabet plus a whole bunch of numbers and symbols and then control characters and so forth. Those were bytes. But what happens when you want to work with multiple languages? Well, this whole byte business breaks down. And so in Python 3, what they've done is they've said, no. Strings, like we have here, are type S, is going to be str, fine. But that str is not containing bytes, it's containing characters. Now that might seem like a really small difference, and if you're using only Latin characters and English letters, then you're fine. Len of S is indeed going to be 5 characters, and back in Python 2, it would have been 5 bytes as well. Why? Because there's no difference between a character and a byte. But when things get more interesting, when you start using languages that are not English, then we start to see a difference. So what happens if here we go, so, I'm located in Israel, so let's say shalom, right? Shalom is how we say hello, goodbye, peace, and we say here len of S. And in Python 3, that says 4, because it's 4 characters. If I want to print the first character there, S of 0, I'm indeed going to get that. And by the way, the shin character there, it is the correct answer. Hebrew, of course, reads from right to left, like a number of other Middle Eastern languages. Okay, fine. How is this interesting? How is this important? Well, back in the days of Python 2, if you had entered this sort of thing, it wouldn't have told you the length of S was 4. It would have told you the length of S was actually 8. And the reason is that each Hebrew character requires 2 bytes. There's just not enough room in ASCII for all of the characters in the world. And so what happened was we all started using Unicode. And Unicode says, let's give a unique identification number to every character ever created by people. Now, it's a bit of an exaggeration. For what I understand, there are characters in languages that don't exist in Unicode, but for the most part, it covers all the characters we want. And by the way, emojis, which everyone loves to use nowadays, those are also included in Unicode, and also stuff that you never would have imagined. So how, though, do we take this very, very large number of characters with its very, very large number of ID numbers and map that into bytes? The answer is we can't do it if we only use 1 byte. It's just not possible. But if we use multiple bytes, we can. So you can imagine having a system where you'd have 2 bytes, 3 bytes, 4 bytes to represent the characters, and these do exist. But the system that Python uses, and that many other languages and operating systems use, is something called UTF-8. And UTF-8 means it's a variable length encoding, meaning if the character existed in ASCII, we keep it the way it is. If it's in Hebrew, Russian, Arabic, Greek, even French, Spanish, those languages that have sort of what I want to say is non-standard characters, but it's a very American, English-speaking centric way to say things. If we need characters that are not used in the US and UK, then you need additional bytes. And so those are going to be 2 bytes long. And if you're using an Asian language like Chinese, Japanese, I believe even Korean, or emojis, then you're going to need 3, 4, maybe even 5 bytes. So that means that when I have here 4 characters saying shalom, it's actually 8 bytes behind the scene. Do I really care? No, I don't care. That's totally fine. I want to work with characters. I want to think about characters. I don't want to think about how it's represented in the memory. I don't care about bytes. I care about characters. Great. But, so in Python 3 now, the modern version of Python, strings are in Unicode. Strings contain any legitimate Unicode characters. All is good. But what if I'm working on the network? And I'm reading in binary data? Well, if I'm working on the file system, I'm reading in binary data. I want to read in a GIF. I want to read in PDF. I want to read an Excel file. Those are not going to be in Unicode because they're not using standard characters. There are characters inside of them, to be sure. But all those binary formatting codes, those don't adhere to the Unicode standard. So in order to work with that, I'm going to need bytes. And a byte string is just like a regular string, except that it has a B at the beginning. B for bytes, not B for beginning. And if I say here shalom, watch what happens now. Oh, I didn't even write it correctly. Let's get those letters in the right order. And if I try to enter this now, what's it going to do? It's going to say, no, you can't do that. You can't take these multi-byte characters and stick them into a byte string. That's just not possible. So how can I do it? Well, I can take S, my string is saying shalom, and I can say s.encode. And if I say s.encode, it's going to give me a byte string with the individual hexadecimal bytes that make up that character. This is the byte string containing what I want. And by the way, if I were to say here something like this, I were to say here b equals this thing, well, that's going to work just fine, because what have I done? I've said hex D7, hex A9, hex D7, X9C, hex D7, X95, hex D7, X9D. By the way, what's this D7 that keeps repeating itself? I'm not entirely sure, but I know that it exists before every single Hebrew character. It might be before other characters also. If I say print B, what am I going to get? Well, it's just going to print me all the bytes. It's not trying to turn them into characters. It's just raw bytes, which is perfect for binary data. If you're reading a GIF, a PDF, a PowerPoint, whatever, and you're going to turn it into strings later, you're going to read commands from it, you don't want these to be in Unicode. By the way, you can say b.encode. Oh, sorry, b.decode. And we'll say, yeah, and I want this to be UTF-8, meaning turn this into a string, interpreting the bytes as UTF-8, and sure enough, we will get our original string back. So if you are doing normal everyday Python programming, even if you're doing it with multiple languages, use strings. The moment you're dealing with binary data from the network, from the file system, I guess from a database, from all sorts of sources like that, you might need to use bytes, and the way to move back and forth between encoding, between bytes and strings is encode and decode. Okay. By the way, when you read from a file, you can actually tell it what encoding to use, and that's a nice little trick you can use if you have to read from a file that's either not in Unicode or that's in an older encoding like ISO 8859-8 or something like that. All right. Hopefully, you won't need to use this very much, but strings only Unicode characters, bytes. Any bytes you want, but they're not considered characters.